Okay, the first question is figure shows the force acting on the body. Each square is 3 into 3 centimeter. If F1 is 30 Newton, F2 is 15 Newton, F3 is 25 Newton, and F4 is 20 Newton, the resultant force and the moment upon point O respectively. So this is what we have to find. So the force we have to resolve in x and y direction, and we can easily find out about the moment also. So what we have to do is we'll find sigma fx then first. So all the x direction, the forces in the x direction now. So F1 is in negative x direction, so we'll take negative 30. So F2 is in positive x direction, so we'll take plus 15, and this is in y direction, so the x component of F4 is 0, and we have this one. So by resolving this F3, what we'll have is we have a slope given for that. So that is nothing but, let me just draw this here, the slope triangle. So this is given as 4 and this is given as 3. So we know that from the Pythagorean triplet this side would be 5. So this angle, so hence cos theta would be equal to, if this is theta, cos theta would be equal to adjacent side, that is 4, divided by hypotenuse, that is 5, and sin theta is given by opposite side, that is 3, divided by hypotenuse, that is 4. So now if I want to resolve this in the x direction, so what I'll have is F3, that is F3 into sin theta, right? So that is minus 30 plus 15 is minus 15, plus F3 is 25 into sin theta is 3 by 5. 5 and 5 into 3 is 15, minus 15 plus 15 is 0 Newton. Alright, so we'll also have sigma Fy. So sigma Fy, so the y component of F1 is 0, the y component of F2 is also 0, and the y component of F3, that is given as this would be coming in this direction, right? That is F3 cos theta. So this is in negative y direction, so we'll have negative sign here, minus F3 cos theta plus F4 is in plus y direction, F4. So if this would be the coordinate system that we'll be choosing here. Okay, so the answer is minus F3 is 25, cos theta is 4 by 5 plus 20. 5 one time and 5 times, and we'll have minus 20 plus 20, that is equal to 0 Newton. So the resultant force is given by square root of sigma fx whole square plus sigma fy whole square. So this is nothing but square root of 0 plus 0, that is 0, right? So this is magnitude, and the moment. So moment about A, so this is nothing but, so F1 would be rotating this in what, anti-clockwise direction, right? So we'll have minus F1 into the distances, each square is 3 centimeters, so 3 plus 3 plus 3, that is 9. So second one is we'll take F2 is tends to rotate from in the clockwise direction, right? So we'll have plus F2 into the distance, perpendicular distance is 3 plus 3, that is 6, and also we have Also we have x component of f3, that is x component of f3 passes through the point O, so that does not contribute to any moment. So the y component of f3, that is f3 cos theta, does contribute to the moment about O, that contributes in the clockwise direction. So we'll have f3 cos theta into the perpendicular distance, that is 9. So, and then we have f4, that is 0, since it is passing through the point O. So this is nothing but minus 30 into 9 plus f2 is 15 into 6 plus f3 is 25 into cos theta is 4 by 5 into 9. So upon simplification we have minus 270 plus 15 into 6 is 90 plus 5 one time and 5 time, 5 into 4 20, 20 into 9, so we have 180. So this is nothing but 0 Newton meter. Okay, so we have second question. We have two men, one stronger than the other, have to lift a load of 1200 Newton, which is suspended from a light rod of length 3 meters. So what they have given that we have a light rod, okay, and at each end of the rod a person is standing and they lifting the rod. The rod is suspended between two persons positions at the two end of the rod. So we have positioned two people. The weaker of the two people can carry 400 Newton only. Okay, so let's say that this point A and point B, at point A we have a weaker person, that is 400 Newton. The distance of the load to be suspended from the stronger person such that the weaker person has the full share of 400. So since they have given full share of 400, I have taken here 400, and we have to place the load and we have to find the distance from the stronger person, that is from B. Okay, and the load that they have given is 1200 Newton. The length of the rod is 3 meter. Okay, so to solve this we'll have to just balance this. So how to balance? We have to take the moment about B. So by taking moment about V, we'll have this 400 Newton contributes in clockwise direction, right? Because this tends to rotate this entire rod centered at P in the clockwise direction. So we'll have plus 400 into the length perpendicular distance, that is 3. And the second one is 1200, that is in the reverse direction, right? So this would be in turning in the opposite direction. So we'll have minus 1200 x, the perpendicular distance is x, but since they are just carrying the load, so the net moment B would be equal to 0. So that is 0 is equal to 1200 minus 1200 x. So therefore x would be equal to 1 meter. Okay, so a horizontal rod AB carries 3 load. Okay, a horizontal rod AB carries 3 loads, so that is 3 kg, 7 kg and 10 kg at a distance of 2 centimeter. We have 9 centimeter, also 15 centimeter respectively from A, where A is hinged. Since they have given that A is hinged, the A can take a moment neglecting the weight of the rod which is at point at which the rod will balance. So we'll have to find a balancing point, right? So to do that, we'll take the moment about A. So we'll have all of this would be in the same direction. So I'll just consider everything to be positive. So what I'll have is 3 into 2 plus 7 into 9 plus 10 into 15. So that is nothing but 6 plus 63 plus 150. So this is nothing but 219 kg meter. So mind that this is in kg, not in Newton. Okay. So to balance this, I'll have to have another force from downwards in the opposite direction of magnitude 3 plus 7 plus 10 is 20 kilogram of 20 kilogram, but I'll have to find this distance x. That is the question that they have asked. So this is nothing but 210 kg meter must be balanced by this 20 into some x kg meter. Okay, so this is nothing but x is given by 219 divided by 20, so that is nothing but 10.95 centimeter. Okay, so next we have question number 4. When two forces A and B are mutually at right angles, the resultant is 10 kilonewton. So if we have two forces, let's say vector A and vector B, if it is 90 degree, so the resultant would be 10 kilonewton. And if vector A and vector B is inclined at 60 degree, so the resultant would be 5 root 6 kilonewton. So we'll have to find what is A and what is B. Okay, so in this equation, this is given by, we know that magnitude of the resultant is given by square root of first vector, that is magnitude of A square plus B square plus 2AB into cos theta. So here AB represents the magnitude. Okay, so the first case we'll take, the resultant is given by 10 kilonewton, that is equal to square root of A square plus B square plus 2AB into cos 90 degree. So we know that cos 90 is equal to 0. So this is nothing but, I'll also shift this square root to the left hand side, so I'll have 10 square, that is 100, is equal to A square plus B square. Okay, so we'll consider the second case. So that is square root, the magnitude is 5 root 6 is equal to square root of A square plus B square plus 2AB into cos 60 degree. So this is given as, if I shift this square root to the left hand side, I'll have 25 into 6 is equal to A square plus B square plus cos 60 is 1 by 2. So that is nothing but AB. And also, so this is 25 into 6 is 150. A square plus b square, we know the value of a square plus b square. I'll just put 100 plus ab. Also ab is given by 50. I can substitute in this equation. B would be given as 50 by A. So that is 100 is equal to A square plus 50 square divided by A square. So I'll have 100 A square is equal to A to the power 4 plus 50 square. So this is nothing but A to the power of 4 minus 100 A square plus 50 square is equal to 0. So if we solve this fourth order equation, we'll have A is equal to root 50. One of the roots would be equal to root 50. So again, so B would be also equal to root 50 if we substitute in this equation. Okay. Next question. If the magnitude of resultant of two forces F and 2F acting at a point P is 50 Newton and included angle between the F and 2F is 90 degree, then what is the magnitude of F? So we have two vectors perpendicular to each other. So the first one is 2F and second one is F. The angle between those two are 90 degree. And they have also given that the resultant is 50 Newton. So we have to find what is F. Okay, so straightforward question. So the resultant is given by the square root of the first vector, that is F square, plus the second vector square, that is F2 whole square, plus 2 into F into 2F into cos of 90 degree. Right, so we know that cos 90 is 0. So this is given by square root of F square plus 2 square is 4 F square. So if I send the square root to the LHS, I'll have 50 square, that is 2500, is equal to 5 F square. So F1 5 one time and 500 time. Okay, so this is nothing but F is equal to square root of 500. So that is nothing but that is nothing but 10 root 5. Okay, so what is the moment of the force acting on a railway signpost shown in the figure? So the moment of force that is acting on point O. So this is point O. We have to find the moment acting on this point. Okay, so to do that, first I will have to resolve this vector. Okay, so we'll have two components. This would be 300 sine 60 and this would be 300 cos 60. Okay, so first we'll take this horizontal component. Okay, so the horizontal component would be, let's say, fx is nothing but 300 into cos 60, right? So that is nothing but 300 into 1 by 2, that is nothing but 150 Newton. And we have y component. Y component is, if I take this is in the negative y, if this is my coordinate system x and y, this is a negative y, so we'll have minus 300 sine 60. So this is nothing but minus 300 into root 3 by 2. Okay, so the moment would be force into perpendicular distance. So first this force would be trying to rotate this post in clockwise direction in the with respect to point O. So this would be positive, so that is nothing but 300, so that is nothing but 150 into the perpendicular distance is 3.5. So the second force, even this force is trying to rotate this signpost in clockwise direction. So we'll have plus 300 into root 3 by 2 into the perpendicular distance is 1.5. So upon simplification we'll have 525 plus 389.7, that is nothing but 914.7 Newton meter. So this is movement about O. Okay, so what is the magnitude of parallel force system shown in the figure? So the question is incomplete. We have 40 kilonewton here, 50 kilonewton here, and we have 40 kilonewton here and 50 kilonewton here. So we'll have to just find the moment about either this point or this point. I'll take this point, let's say A. So sigma MA is given by, so this 40 Newton, the first force is passing through this point, so this contributes 0. This has no contribution to the moment about E. The second force, that is trying to rotate this body in clockwise direction, so I'll take it as positive. So that is 40 into the perpendicular distance is 2. The second one is 50 plus 50 into the perpendicular distance is 4. And the last one is, this is trying to rotate the body in anti-clockwise direction, so that's why I'll take it as negative, the sign as negative. 50 into the perpendicular distance is 3 plus 2 5 plus 2 7. So upon simplification I'll have minus 70 kilo Newton meter. Straightforward. So here the minus represents the net moment, that is the net moment would be anti-clockwise direction. Okay. So a string 2 meter long is tied to the ends of a uniform rod that weighs 60 Newton and 1.6 meter long. The string passes over a nail so that the rod hangs horizontally. What is the tension in the spring? So they have given that we have a rod here, okay, and the ends of the rod has been tied by a string, and the string is hanged by a nail, right? So approximately, so this is something like this. So the total length of the string is 1 meter. So since the rod is hanged horizontally, this would give us an isosceles triangle, and since the total length of the string is 2 meter, I'll have to take 1 meter and 1 meter here. So the length of the rod is given as 1.6, right? So if I take this half of the triangle, which gives me the Pythagorean triplet 1, 0.8 and 0.6. Because of the isosceles triangle, the base would be the half here, right? So this is 90 degree. So we know that. Let's find this angle. So that angle is given by, I'll take tan. If this is theta, I'll take tan theta is equal to opposite, that is 0.8 divided by adjacent. So theta is given by tan inverse of 0.8 divided by 0.6, so that is 53.1 degree. Okay, so this angle we have found out that it is 53.1 degree. So what about this angle? So that is nothing but 90 minus 53.1, that is 36.8 degree. Okay, so the weight of the rod is given by 60 Newton. Okay, so I'll have to find the tension in the rod. So I'll have to find what is this and what is this. Okay, so to do that, I'll have to resolve this 60 Newton in the direction of the string, right? So to do that, let's draw the free body diagram. So to draw the free body diagram, before that, so to get this as the resultant, I can simply add two forces horizontally, right? So in equal and opposite direction, one here and the other one here. Since these two, let's take it as S. Since these two vectors cancel each other, there won't be any changes in the equation, right? So now we can resolve this. If I write the free body diagram, I can take the only half of this. So I'll have this S and also this resultant, and the weight component would be 30 because I'm only considering the half of the diagram. So this angle is given by 53.1, this is 36.8. so this is the one that we'll have to find out. So to do that, if I resolve this in terms of this, that is r cos of that is nothing but r cos of 53.1 would be equal to 30 Newton. So now r is equal to 30 divided by cos of 53.1. So that is nothing but 30 divided by cos 53.1 is 0.6. So 30 divided by 0.6 is 50 Newton. So this tension in either side of the string is given by 50. So this is how the free body diagram looks like for the tension. Okay, so if two forces 10 Newton act at an angle of theta, then what is their resultant? So we have two forces 10 Newton and 10 Newton. The angle between them is theta. So what is the resultant? So we'll have to find the resultant. Straightforward, resultant is given by square root of the first vector 10 square plus the second vector 10 square plus 2 into first vector into second vector into cos theta. So we'll have square root of 100 plus 100 plus 2 into 100 into cos theta. So that is nothing but, if I take 100 common, so square root of 100 is 10 into square root of 1 plus 1 plus 2 cos theta, right? So this is 10 root 2 plus 2 cos theta. Okay, so I can write cos theta as 2 cos square theta by 2 minus 1. Okay, so if I substitute that, I'll have 10 into square root of 2 plus 2 into 2 cos square theta by 2 minus 1. So that is nothing but 10 into square root of 2 plus 2 cos square theta by 2 minus 2. So plus 2 minus 2 gets cancelled. So I'll have 2 plus 2 is this 4. Square root of 4 is 2. 10 into 2 into cos theta by 2. This is nothing but 20 cos theta by 2. So this will be the magnitude of the resultant.